What up? It me, your boy. We're gonna bang out some sweet uh, nuclear decay equations. We gonna write them out. We gonna see what's good. All right, I'm sitting out in the middle of my house right now. So if any of my roommates come true, just be chill. They won't even know. I'm just gonna be like, "What's up, doc?" And they're gonna be like, "What's up?" You feel me? We feel each other. All right, carbon 14. So I started off here with something we've seen a few times before. Carbon 14, one of the most common types of radioactive decay that we look at because of carbon dating, which we talked about in class. So we got carbon 14. It's carbon, so it's got 6. That boy too thick. Okay, carbon 14 undergoing decay. So you've already seen this equation before, but I thought it would be a good first one to give you guys to kind of refresh on writing them out. So it's undergoing beta decay. And I also want to say before I start putting the answers in here, these are 100% questions that you should attempt on your own before watching this. Okay, do as much as you can on your own. That's how you're going to get the most out of it. And then use this to confirm your answers, or if you're really stuck on something, use this to see how to get past that one thing and then finish on your own. That's how you're going to get the most out of it. But at the end of the day, you can kind of do whatever you want with your education. It's in your hands. Okay, carbon 14 undergoing beta decay. Okay, beta, like we talked about up here. So I'm gonna just keep the blue going with beta. Almost dropped my pen. That would have been really funny if you guys could see it, but all you could hear is me make weird noises. Okay, beta decay, emitting a beta particle with no mass and -1 charge. Okay, so like we talked about up here, beta decay is a neutron giving off this beta particle, this electron, and becoming the neutron's becoming a proton. So we're gaining 1 proton in this decay. That means that the atomic number, hold on, gotta let her know not to text me. Okay, I could have gotten, well, I actually really wouldn't have gotten anything, so I don't know. All right, nitrogen, do it in this color. Oh, I gave away the answer. So what we know is that the protons are increasing by 1. So now we have 7 protons. If we have 7 protons, it has to be nitrogen. Can't be anything else with 7 protons. Protons define the element, blah, 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 blah. Okay? Is the mass changing? No. Beta particles have no mass. You're not losing any mass. You're not gaining any mass. So that stays 14. And that is how you would write this one out. Okay? Let's look at the next question. We're not given the type of decay it is. We're just told to write out this going to this. Okay, so let's get a sweet color, feeling a little green. Okay, so we have TH 230. Okay, atomic mass of 230, and it is becoming. Oh, drop my pen again. Purple. Oh, somebody's alarm's going off. One of my roommates about to pop out here. Gonna be Maddock. All right, it's going to. We don't know what the decay is going to be yet, so we're going to figure out. But we know that this is going to be this 226. Okay, so you would have had to find these on your periodic table. They are. Thorium is in the. We talked about it before at one point. It's in the actinides, the very first one, the actinides. So I can look at my periodic table and I can see that the color, or not the color, switching colors. The atomic number for thorium is 90. Okay, and I can find Ra, which is radium. I lost it for a second there. Radium, the atomic number is 88, so that's going to be 88 no matter what. Okay, so now we look. What is the change here? So we see that the 90 of thorium right here got reduced to 88, dropped by 2. So that should be enough to already tell you what's going on here. So we know that we had to lose 2 protons, and then 230 went to 226, so we lost 4 total atomic mass. So something with 2 protons is going to be helium. So we lost a helium nucleus here, we lost the 2 protons and 2 neutrons. And up here, we know that that is alpha decay because that is what an alpha particle is. So we wrote it out. I guess you weren't asked to actually identify the type of decay, but obviously from this, you know that it's going to be alpha decay in this equation. All right, one more. Let's pop this. Why am I talking like that? Who have I become? Okay, nice maroon F-22 Raptors for those of you in the Air Force. Who are you talking to? F-22, okay? So we have fluorine, atomic mass 22. Fluorine always has 9 protons, or else it wouldn't be fluorine, as we know, okay? So this is decaying, and we know it's going alpha decay. So this is an interesting question because I said write the decay series, and I gave you multiple steps. So F-22 undergoing alpha decay, followed by beta decay, and the emission of a gamma particle. So I like to do this with the last question, kind of bring it all together with a bunch of stuff. So we know that first of all, it's undergoing alpha decay. So I'll do that in the original color of alpha decay that we did up top. So we know it's losing a helium nucleus. Okay, and if it's losing that, then we know that 9 is going to go down by 2. It's going to be 7. 22 is going to go down by 4. It's going to be 18. And anything with 7 protons with an atomic number of 7 is going to be nitrogen. So once again, we have nitrogen as one of our products, this time with 18 for the atomic mass. So 4 more protons than it had up here. Okay, so now it says followed by beta decay. So now we need to draw this undergoing beta decay. So losing an electron as a proton becomes, or as a neutron becomes a proton. Okay, so it's undergoing beta decay, and it is gaining a proton, so now it's going to be 8, and if it's 8, that means we're working with oxygen now, and the atomic mass doesn't change because that's 0. So now we have oxygen, oxygen 18, an isotope of oxygen, and we're also releasing a gamma particle. Okay, and gamma has no mass, no charge, so it's just there. It's just acknowledging that this happened, and it tells us that in the question step. You wouldn't really know that otherwise because there's no mass and no charge. Okay, so I don't think really any of you struggled that much with this that I saw in class, but this is how you write out equations. If you're given anything undergoing either or any 3 of the 3 types of decay, you should be able to write out what happens in this format, understand what the different particles are, what they do, and what the elements become. All right, in the next video, I will start going into these half-life equations, calculations. So this is where stuff gets a little trickier. And then there's a big, beautiful question at the end with everything you could possibly imagine mixed in. We will get to that soon. All right, I'll see you guys in the next video.